welcome to an algebra tutorial video working our way through linear graphs and understanding slope. We're going to learn specifically how to find the slope of a line if we're given just a table of points. So here we got a table of points here. We got x is -2, -1, 0, 1, 2, and 3. And have some changing y values, -10, -7.2, -4.4, -1.6, 1.2, and 4. And these are all points. I could plot them on a graph, but they're all representative of a linear relationship between x and y. As I change these x values, here's the y values in response. So let's take a quick moment reviewing slope. Slope is just the average rate of change between 2 points. So if I have 2 points, I want to know, well, how much am I changing along x and how long am I changing along y? Another way to think about slope is, I'm going to do a couple other definitions here. When I think about this average rate of change, I want to look at how much is changing on the y values, change in y, divided by the change in x. So again, that's another way to find rate. How much am I changing on my two different things? And when I divide them, that gives me my average rate of change. Another way to write it, or to think about change, is the difference between the y values of 2 points. If I subtract my y values, that's going to tell me how much change happened in the y values. And if I subtract the x values, that's how much change happened in the x values. Okay, so there's, again, defining out slope, thinking about slope, all these different ways of understanding what the slope is. But let me look at the patterns in my table here. If I look from -2 to -1, we change by +1. At the same time, how much do we change along my y values? Well, from -10 to -7.2, if I take those values, -7.2 minus -10, and if I subtract them, we see that it equals +2.8. All right, let's look at the next change here. So if I change another one for x, from -7.2 to -4.4, if I subtract those, we also end up changing by 2.8. Change another one value for x, we see that from -4.4 to -1.6, that's also a difference of increasing by 2.8. This pattern will continue along the whole entire table. It's actually representative of what a linear pattern can look like in a table. Because I changed 2.8, again, that's my change in y values, so 2.8. Every time I change an x value of 1, that's my slope, 2.8 divided by 1, which just equals 2.8. So another way to think about it, what if we have a table of values that isn't lined up very nicely? What if there's big jumps, or what if it's not a consistent deal? We can still think about that because all I need is 2 points to find the average rate of change. So I'm going to take this first point here, the -2, -10, and then 3 and 4, and think about it in terms of this formula. All right, so from -10 to +4, how much change is happening there? Well, 4 minus, if I subtract them, -10 is going to be equal to 4 plus 10, which is 14. So there's a change of 14. From -10 all the way to that 4 there, we added 14. So in my y values, because that column represents my y's, we looks like we added 14. So I can think of a change of 14. Well, while I'm changing 14 in my y values, how much did I change in my x values for those 2 points? So I'm going from -2 to 3, that's a change of +5. So as I changed 14, I changed by 5 in a positive value, and now I divide them to get it in a rate. So 14 divided by 5, guess what that turns into? That also turns into 2.8. So we used, again, I used a change in y divided by the change in x for this first one, and then the second one I actually subtracted y values, subtracted x values, and got the difference in the change and was able to still divide them and get the same answer, same slope. So the whole point is, if I'm given a table of values, that's a bunch of points, and I only need 2 of them to figure out, well, how much change is happening in my y values and how much change is happening in my x values. And then I can divide them, and any 2 points off this table will give me the same exact slope of 2.8. So the slope from the table is 2.8. That's how much change is happening in y for every change of 1 for x. Hopefully that's helpful for you in thinking about slope and finding the slope from a table of values.